Assalamualaikum and hello everyone. My name is Muhammad Faris Merozaidi. I am from class JCS 1431D and this is my member.
My name is Suhaiza Miti Jumali and I'm from JCS 1431D.
Hi, my name is Nur Nadira binti Muhammad Rahaidi.
So for today, our group are going to talk about the application of geometry in real life. Geometry got a lot of real life application, but for today, we are going to talk about application of geometry in architecture. Our group chose the Blue Mosque Istanbul and the Pentagon, USA as our cases.
So today I will present about the Blue Mosque at Istanbul. But first, let's talk about history of this building. The Blue Mosque, as known as the Sultan Ahmed Mosque, was built between 1609 and 1616, was meant to resist Ottoman power even though Ahmed I had to procure funds from the treasury since his leg in victory also meant a leg in spoils of war. The Blue Mosque was commissioned by Sultan Ahmed I when he was only 19 years old. It was built near the Hagia Sophia over the site of the ancient Hippodrome and Byzantine Empire Palace. The mosque was designed by architect Mehmet Aga. Just like many other mosques, it also comprised a tomb of the founder, a madrasa, and upsides. Besides, still used as a mosque, the Sultan Ahmed Mosque has also become a popular tourist attraction in Istanbul. The mosque is 64 by 72 meters in dimension. The central dome is 43 meters in height and is 33.4 meters in diameter. And also, the Blue Mosque have 6 minarets. So therefore, Mehmet Aga supports the central dome of the Blue Mosque with 4 half dome and many quarters domes. The elegance of this dome gives an equal-side look from the outside. Decoration starting from the top of the column, it extends to the dome through the arch and gives a sense of integrity. The entire of the mosque has been extended to the side and gained deep thanks to the half and quarter domes. The Sultan Ahmed Mosque is the first of the 2 mosques in Turkey that had 6 minarets.
The history of the Pentagon building. The Pentagon, United States of America. The Pentagon is the Virginia headquarters of the United States Department of Defense. The Pentagon located in a massive 5-sided concrete and steel building. The building is a potent symbol of America's military strength. The Pentagon ranks among the largest office buildings in the world with more than 6 million square feet of the floor space. The Pentagon was built during World War II on September 11, 1941. Surprisingly, it is exactly 60 years to the day the terrorist attack of September 11 happened. On September 11, 2001, a hijacked plane struck the building. The terrorist attack damaging roughly a third of the building and killing 189 innocent people. When Sommerville lead architect J. Edwin Burstom drew up the design for the structure, the existing roads at the site forced him to use an asymmetrical 5-sided shape which is pentagon. Then, to accommodate wartime steel problem, he decided that the building that he about to build will not more than 4 floors high. The Pentagon get its shape because the land on which the Pentagon was first spanned was bordered by road on 5 sides. So, the architect constructed a 5-sided structure.
Okay, right now, I'm going to talk about applications involved in these cases. Some people might remind themselves about lines, angles, shapes, and the measurement of the shapes if they heard the word geometry. It's true, but geometry context is bigger than that. Geometry affects our day-to-day basis. All around us is a measurement, with visual impression either described or perceived. For this project, I'm going to concentrate the application of geometry in architecture. Geometry plays an important role for both designing and building certain structures. Geometry is used by the architect to divide spaces, as well as design plans. To construct safely, builders and engineers rely on geometric principles. Architects need to make a plan or blueprint before the construction of the build the structures. In order to sketch the design, architects apply this geometric principle. The Blue Mosque, Istanbul and the Pentagon, USA is the example of geometry in real life in architecture. These two buildings combine a lot of shapes to create one unique and beautiful building. For example, the Blue Mosque shape can be modeled by many mathematical objects such as spheres, hemispheres, cylinders, and semi-cylinders. All these shapes has its own purpose. For example, the mixed shape semi-cylinder and hemisphere around the mosque are used to support the main dome of the mosque. The Pentagon, also a building where several shapes is combined such as isosceles triangle, right angle triangle, trapezium, square, and rectangle to create such a unique building. So this is the example of the Pentagon sketch. You can see the square shapes, the regular Pentagon shapes, and the combined right angle triangle. All these shapes can be calculated using mathematical formulas according to each shapes. Each shape has its own unique formula for finding the measurements such as volume and area.
So I proceed with the mathematical calculation for the Blue Mosque Istanbul. So we go through one by one that what I have calculated at this part. So first we go for the area. For the first shape in area, I'm search for big hemisphere that I assume as a dome. For this area section, I searching for the surface area only. So I will write down formula area circle. For pi, I'm using either 22/7 or 3.142 for pi value. So first, I'm search the radius value, which is half of diameter. They have been given diameter value, so 33.4 divided by 2, and I get 16.7 meter. So I enter the value in the formula, and I get 876.511 meter square. For the final answer, I'm using 3 decimal points. You also can 4 decimal point or 2 decimal point. It's up to you. So for the second shape is rectangle. So they have been given length and width value. So I enter in the formula, which is length multiplied by width. So I enter in the formula and I get a final answer, which is 4,608 meters square. So the third shape is form mixed shape of semi-hemisphere and semi-cylinder. So I have to write down formula area semi-hemisphere and formula area semi-cylinder. For the radius value, I'm using previous answer, and pi also I'm using either 22/7 or 3.142. So first I'm search for area semi-hemisphere. So I enter the value in the formula, which is this formula. So I get the final answer is 1,753.023 meters square. So the second one, I'm search the area for semi-cylinder. So I enter the value in the formula, which is this formula. For this formula, they have mentioned height. So they have been given value of height, which is 9.6 meter. So I enter the value in the formula and I get the final answer is 1,380.374 meters square. So for the final one, I'm search for the total of 4 mixed shape, which is semi-hemisphere plus hemi-cylinder. So 1,753.023 plus 1,318.374 multiplied by 4, and I get the final answer is 12,533.588 meters square. So next one, I'm searching for the value. For the first shape in value, I'm using for the sphere. So I have write down formula volume sphere and radius value for the previous answer. And pi, I'm using either 22/7 or 3.142. So I enter the value in this formula value sphere, and I get final answer is 19,516.988 meter cube. So for the second shape is big hemisphere. So I have been write down the formula volumes hemisphere and formula area circle. So I enter the value in this formula and I get a final answer which is 9,758.494 meter cube. For the third shape is big cylinder. They have been given diameters. They have been given value of height which is 26.3 meter. So I have been write down formula value cylinder. So I enter the value in this formula. So I get final answer 23,052.251 meter cube. So for the fourth shape, I search for mixed shape of semi-cylinder and semi-hemisphere. So I have been write down formula volume semi-cylinder, formula volume semi-hemisphere, and formula area sphere. At this part, they have been given radius value and height value, which is 9.6. So first, I'm search for volume of semi-hemisphere. So I enter the value in this formula. So I get final answer is 4,879.247 meter cube. So the second one, I find value of semi-cylinder. So I enter the value at this formula and I get final answer 4,207.255 meter cube. So for the last one, I search for total of 4 mixed shape which is semi-hemisphere and semi-cylinder. So total of volume semi-hemisphere plus total semi-cylinder I multiply by 4 and I get final answer 36,346.008 meter cube. So this is how I search for the all shape which is in area and volume.
As we all know, the Pentagon building are named by its own shape, which is pentagon. So let's discuss how to find the area and the volume of the building. First, we find the interior angle of the pentagon, which is 108 degrees. Then, we select the upper term to find the area. So, first we find this angle. We just divide this value by 2. So we get 54. Then we find this angle. Just subtract it with 180, subtract 90 and subtract 54 which is 36. So here is 36. Then we can find the upper term. This is the upper term. The upper term is 193.38 meter. So now we can find the area for the building. For the area, we can use two formulas. For the first one is half times upper term times perimeter. Perimeter is 281 times 5. This 5 is the number of sides for the building. So the Pentagon has 5 sides. So we get this value. So just put it in the formula and we get this value. For the second formula, we use half times n times r square times sine 360 over n, where n is number of sides and r is the radius. So the number of sides is 5 and radius is 239.0319. So just put it in the formula and we got this value. As you can see, it is the same value even though we use a different formula. For the volume, it only has one formula which is area of the pentagon times height. The height of the pentagon is 22 and we just times it with the area of pentagon and we get 2,688,687.9. I found another way for the area of the pentagon, which is using the same triangle as before. So,
For the area of the triangle, formula is half times length times height. The height is OF, which is equivalent to the upper term. So we just put it in the formula and we have the area of the triangle. To find the area of the pentagon using the area of the triangle, we just multiply it by 5. Why? Because as you can see, the pentagon area are same with 5 triangle, which is 1, 2, 3, 4, and 5. So we just put it in the formula and we have the area of the pentagon. For the volume, we just use the area of the pentagon and times the height, which is 22, and we have the volume of the pentagon.
In conclusion, geometry is a branch of mathematics that deals with points, angles, surfaces, and solids. For most of the people, geometry requires figures and angles for a lot of mathematics. Nevertheless, it is not about calculation only, but it involves with many theorems. The usage of geometry not limited to building construction, home and landscape design. In addition, geometry has expanded to astronomy, games, and sport to their frontiers. When we first began our group project, we had no understanding about the application of geometry in real life. We began to gain knowledge from it after several studies. We have learned many things in this group project, such as teamwork, data collection, analyzing, and even applying the theory of geometry in measuring the buildings. We would like to thank our lecturer, Madam Azlina, for guiding us through the end of this project. That's all from us. Thank you.